Hello and welcome to Homework Walkthrough Video 8.02b, Independent Practice. Question 1. The coordinates of a point are given -5, comma 4. So we went over to -5, then up to 4. Gotta shuffle on the carpet before you climb up the stairs. Okay, what are the coordinates of a point that has a distance of 4 units to the right? 4 units to the right of the given point. Let's see. 4 units to the right. So here's my snip. Zoom in a bit. Here we go. 4 units to the right. So right is this way. 1, 2, 3, 4. Right here is where it is. Now I can't type right here as my answer, right? That'd be silly. I have to write the coordinates of the point. The coordinates of the point. 4 units to the right. So I have to write the x and y values, the ordered pair. How far over did we go? How far did we shuffle on the carpet for this new blue point? -1. That's how I should say again. I should say that differently. How far from the origin can we shuffle on the carpet to get to this point? Not how far over did we go from this black point. How far over did we go from the origin? So we start at the origin and we shuffle once to get to this blue dot from the origin. How far did we go? We went -1 from the origin. Now again, from the origin, how far up or down do we go? 1, 2, 3, 4. And that's the line the dot's on. Up 4. So from the origin, we go over to -1, then up 4. These are our coordinates. -1, comma 4 with the parentheses. With the parentheses. Oh yeah. Question 2. The coordinates of a point are given. What are the coordinates of the point with a distance 5.4 units left of the given point? Left of the point. So let's get a coordinate plane picture. Thank you, Google Images, for this wonderful coordinate plane. Snip. And back to our work. So I want to know, so I go over about where it is. 6.5 and 4. So I go over to 6.5 and up 4. Over to 6.5, which looks like my graph's not big enough. Be right about here, 6.5. And then up to 4. So this about is where my dot would be. Now, right, 6, a little half jump. Here's where my dot would be. 6.5, comma 4. I want a unit that goes 4.5 units to the left. So this way. When we go to the left, that is just the most awful looking arrow. When we go, that's better. That's left. When we go to the left on the coordinate grid, what's happening to these x values? Are they getting bigger or are they getting smaller? Look, as I draw my arrow, are these numbers getting bigger or smaller if we go to the left? They're getting smaller. So I think whatever answer we put here the x value will be smaller than 6.5. And okay. Since we don't have a graph for this question, and since there's decimals, maybe the graph isn't the most efficient tool. Let's try and use a subtraction formula. Since the number is getting smaller, we can subtract. Also, since the height isn't changing, the y value doesn't change. Let's draw this out. So coordinates have an x value and a y value. The x value tells you how far over you go from the origin, how far away from the origin you go to the left or right. The y value tells how far up or down we go. Since we're staying at the same height, I know that my y value is going to stay as the number 4 for my answer to this question. But my x value is going to change. Since we're going to the left and our numbers are getting smaller, I'm going to try using subtraction. And we went to the left 5.4 units. So I will do 6.5 minus 5.4, which is the handy-dandy calculator. 6.5 minus 5.4, 1.1. Okay, and that makes sense, because 1 and 6 are 5 away from each other, and 0.4 and 0.5 are 1 away from each other. So that makes sense. Net 1.1 comma 4. That'd be about right here. 1.1 comma 4. Don't forget the parentheses. So we used subtraction because we went left. So that means if the question asks us to go right of our original point, that means we're going to add because the numbers will get bigger. Cool. Find the distance between these 2 points. Since we don't have a graph for this question, let's use a subtraction formula. When you don't know, let's use a subtraction formula. The formula we can use is the first x minus the second x, and then find the absolute value of that difference we find, meaning just turn it into a positive, and that will equal the distance. Okay, let's put this into action. The first x value is 4.4 minus the second x value is negative 1.9. Absolute value. So this is going to, absolute value means my answer will be positive, no matter what. It'll be a positive. Whether or not this gives me a negative or a positive, my final answer will be positive. That's what absolute value does. So subtracting a negative is the same thing, like losing a loss, that's the same thing as adding. Losing a loss is a gain. If you lose a bad thing, like you're no longer sick anymore, that's good. That's adding. So I'm going to rewrite this in a more simple way, 4.4 plus 1.9. Minusing a negative is the same thing as plusing. Absolute value. Okay, let's see what Monsieur Calculator says our answer is. 4.4, 6.3, and also 4.4 minus negative 1.9 is also 6.2. And the absolute value of positive 6.3 is 6.3. Absolute value turns all numbers into a positive, even if they were already a positive. So our distance is 6.3. Question 4. Find the distance between these 2 points. Now, we don't have a graph for this question, and this question has decimals, so I don't even know if a graph would help us that much. So let's use a subtraction formula. A formula we can use for this question is x1 minus x2, and then find the absolute value of that difference, meaning we turn it into a positive, even if it starts as positive. And that will equal the distance. Let's put this formula into action. The first x value, so the x value is the first number in the pair. The first x value is -3 minus, the next x value is -4.2. No, not parentheses. And we're finding the absolute value of this. When we subtract a minus, when we lose a loss, if you're no longer sick, that is good. It is the same as adding or gaining. So let's rewrite this in a more simple way. -3 plus 4.2. It's like these two minus signs jumped on top of each other to turn into a plus sign. And let's type that in our calculator. -3 plus 4.2 is 1.2. Now, just to prove that two minus signs can turn into a plus, let's type it in our calculator the other way. 3, but it's a negative, minus 4.2, but it's a negative, is 1.2 still. 1.2. And we're finding the absolute value of 1.2, which is positive 1.2. Absolute value turns all numbers into a positive, even if they're already positive. So our distance for this question is 1.2. Question 5. The graph shows the plotted points over 6 from the origin and up 4 from the x-axis, and over 5 from the origin and up 4 from the x-axis. Use the graph to find the distance between the 2 points. Oh, tricky, tricky, tricky. It looks like the distance is 2, but the distance is not 2, even though it's 2 jumps, because each jump, it looks like, is half of a number, is 0.5. So I think our distance is 1, right? They're 1 away. 5, then 6. We can use that subtraction formula we used for question 4 in this video and do one x value minus the other x value. So yep, our distance is 1. Ooh, a little tricky graph on this question. The graph shows the plotted points. -8. Over to the left 8, then down 5 from the x-axis. Then over to the left 3 from the origin and down 5 from the x-axis. Use the graph to find the distance. Okay, it looks like on this graph, also, each jump is not worth 1. Each jump is worth a half. Like 0.5, 1, 1.5, 2, 2.53, 3.54, 4.55, 5.56. Each jump is a half. So let's see the distance of this graph. Let's see if each jump is a half. So I got half, 1, 1.5, 2, no, yes, 2. Oh, I lost count. 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. Okay, I think it's 5. But let's use our subtraction formula. First x minus the second x, and we find the absolute value of that, meaning we turn it into a positive. So first x is -8 minus the next second x is -3, which is -5. Oh, but we're finding the absolute value. Absolute value turns all numbers into a positive. So, okay, it is confirmed. We counted right. We used mathematics to prove our answer here is 5. One more question. The graph shows a plot of points 1, 5, -4, 5. Use the graph to find the distance between the points. Looks like for this graph, each jump is worth half, like 0, 0 0.5, 1, 1.5, 2, 2.5, 3, 3.54. That checks out. So each jump is not worth 1. So let's count using that knowledge. So 0 0.5, 1, 1.5, 2, 3.5, 3. Oh, I lost count. 0 0.51, 1.52, 2.53, 3.54, 4.55. Okay, we think it's 5. We think it's 5, but let's prove it with mathematics using our subtraction formula. The first x minus the second x and the absolute value of that. So the first x is 1. The second x is -4. Find the absolute value. Let's type that in our calculator. 1 minus 4, but it's a negative. 5 absolute value, and the absolute value of +5 is 5. Absolute value turns all numbers into a positive, even if they were positive already. Now, we could have also typed in 1 plus 4, because minusing a negative is the same as adding. Losing a loss is the same as gaining. No longer being sick is good. Minusing a negative, same as plusing. So both of these 5. Okay, looks like our distance for this question is 5. We proved it with counting. We proved it mathematically. All right, if you need more help with this homework, let me know. I'd love to help. Good luck and goodbye.